The broadcast is now starting. All attendees are in listen-only mode.
Good morning, and thank you for joining us for this TriStar-sponsored webinar. Today we have with us Paul Sagar, PTC's Director of Product Management. Today Paul will be giving us a high-level look of Creo 3.0. Before we get started, I'll address a few things logistically. First, should you have any questions during the presentation, please enter them into the Questions tab in your GoToWebinar interface. We will address as many of these questions as we can at the end of the presentation. Second, this presentation is being recorded. Once the presentation is over, it will be loaded into the TriStar Resource Center to be viewed. You can find the Resource Center by going to tristar.com and clicking Resource Center at the top right of the page. We will try to have the video up by the end of the day. With that out of the way, I'll hand things over to Paul.
Okay, thank you. Good morning, everybody. Just to repeat, my name is Paul Sagar. I'm Director of Product Management for Creo. I have overall responsibility for Creo Parametric. In today's session, though, I'm going to give you a high-level look at some of the exciting new capabilities that we've added in Creo 3.0. Now, you hopefully are aware of this circle of apps that we currently have and the Creo strategy around building a scalable, interoperable suite of product design software that offers faster time to value. Now in Creo 3 we've enhanced a fair portion of the individual apps in this circle. We haven't added enhancements to all of them, but for example there's enhancements in Creo Parametric, in Simulate, in Creo Direct, in Layout, in Creo Sketch, etc. So what I'm going to do is we can break the enhancements in Creo 3 down into three main areas. So I'm going to present them in the form of themes for the release. The first one is to really talk about and focus on our new breakthrough capability for working with multi-CAD data, something we call Unite technology. So I'll spend quite a bit of time talking about Unite technology, what it is, and how that can benefit yourselves. Secondly, I want to talk about improvements we've made in concept design, whether it be 3D concept design or 2D concept design. And then finally, I'll go on to some efficiency and productivity improvements we've made in the Creo suite. So to begin with, let's take a look at Unite and the multi-CAD capability. So Unite really can be broken down into four main areas of capability. The first one is the ability to import in 3D CAD formats. So we will support, or we do support, the import of SolidWorks, CATIA, NX, Inventor, and Solid Edge. Now, what's different here is the fact that now you no longer need any third-party application to be able to import that data in. Straight out of the box, for every maintenance-paying customer, you will have the ability to, say, file, import all of those formats. Secondly, we're adding capability called Open that will allow you for SolidWorks, NX, and CATIA data to directly open that into your Creo session. And I'll speak a little bit about what the differences are between open and import as we move forward. In addition, Unite technology gives you the ability to receive automatic updates from that opened data. And finally, it also allows you the ability to save as those three key CAD formats. Excuse me. So the best way to really talk about Unite is to focus on particular use cases. And there's two main use cases. The first one is consolidation, and the second one is collaboration. So let's take a look at consolidation. So why would you want to consolidate? Well, it might be you're in an organization where you've got multiple different CAD systems. Now, if you're somebody who works in IT, that can be time-consuming, it can be expensive to support and maintain and upgrade multiple CAD systems. Ideally, you want to have a single CAD system, a single provider that you can go to when you've got problems or issues, or you've just got one provider to go to perform your updates. If you're an engineering manager, you care about consolidating to a single CAD platform because that gives you the freedom to distribute your work more effectively within your organization. If different parts of your organization use different CAD systems, it's very difficult for you to distribute a project to different teams, as those teams may not use the same CAD system. So as I mentioned, out of the box, with Unite technology, you're going to be able to import as well as open certain data. So let's take a look at what the difference is between the two. Well, sorry, before I get there, let's take a look at the consolidation challenges that you have. Now, if you make the decision that you want to consolidate down to a single CAD platform, how are you going to do that? You've got to go through a process of converting your legacy data to a format that can be used and leveraged in your new CAD system. So there's a number of different ways that that can be done. First of all, you could go through a process of doing 100% upfront conversion. So before you even switch, you're going to take all the legacy data that you've got and you're going to convert all of that information into your new format. Well, that's obviously a very time-consuming process. It has a very high upfront cost associated with it. Alternatively, you could do more an on-demand conversion. This is whereby as you're deciding to work on a new project and you need to reuse some information from a legacy system, at that stage you do the conversion. Now this has less upfront cost and overall it has less cost, and you're distributing that out throughout the project. Now what Creo 3 does is allows us to take that blue curve and push it down even further. Okay? So rather than converting everything on demand as and when we need it, we don't necessarily need to do that. If I've opened up an assembly of 1,000 parts, maybe in my design I'm only going to change 1 or 2 of those parts. There's no reason to convert the other 1,000 parts. So how's Unite going to help you do that? So first of all, let's take a look at the difference between import and open. So in the case of import, let's say I've got a SolidWorks assembly, and I'm going to say File, import that SolidWorks assembly. So again, straight out of the box, you're going to be able to say File, import, and what that does in essence is make a complete copy of your SolidWorks data and represents that copy inside Creo. What that means is you've now actually got 2 business objects to manage. You've got the original SolidWorks data to manage, and you've got the new Creo data to manage. But in essence, you've converted everything. Let's take a look at how open differs from that. In the case of open, I'm going to take that same SolidWorks assembly, and I'm going to open it up inside Creo. Now in this case, I haven't converted any data at this point. I've simply opened it up and I'm representing it inside Creo, the BREP information inside Creo without doing any conversion. So I've not got any additional business objects to manage. All I have is my original SolidWorks business object. Now if at any point in time I decide that I need to make a change to one of those parts, Creo will be smart enough to say, hang on a minute, this part is not a Creo part. I therefore need to convert that part to a Creo part to allow you to do that conversion. And if you agree to that and say yes, Creo will then convert that part as well as any additional parent subassemblies that part might exist in. So whereas in the import case, I've taken my entire assembly and I've converted everything to a Creo assembly and Creo parts, in the open case, all I've done is actually converted 2 parts, or 1 part and 1 assembly. So I've reduced the overhead that is needed in the conversion process. I've reduced the overhead in managing that amount of data. So I've got much less information to manage, and my IT department is going to be much happier. So let's take a look at that in action. So here I'm going to open up an assembly of a truck. This is a Creo assembly, but I need to work on the cooling system, and I need to bring in the radiator assembly. Now this radiator assembly is actually done in NX, so I'm just going to simply take that NX assembly and open it up. I can then assemble that appropriately. And what you'll notice in the model tree is I now have different icons representing that data to tell me that it is not Creo data. If I now want to go and make a design change, in this case to the fan, the system's going to tell me this isn't a Creo object and I need to convert it. And the system will automatically convert it, and you now notice in the model tree I have Creo objects for those components. So using flexible modeling, I can easily come in now and alter the diameter of my hub. Maybe I want to change the number of fan blades. So I can, again, use flexible modeling to make those changes very quickly. Maybe I also want to change the outside diameter of the fan. And with it being a bigger fan and more fan blades, I probably also want to change the number of fasteners I have for that. So again, using flex modeling, I can recognize the pattern of geometry, I can change the number of instances, and update it accordingly. Now in addition to that, with Creo 3, we've introduced a new intelligent fastener library. So that allows me to very quickly and easily assemble in fasteners into my model, as well as pattern those automatically. So very quickly I have loaded up an entire NX assembly, and I've made a change to just one or two parts of that assembly without burdening the organization with managing additional unmodified data. So that, in essence, is what you will get in Creo 3 out of the box. So that's going to allow you to reduce the number of CAD platforms you have to support. It'll allow you to be more effective in your engineering organization, to distribute that work throughout. And it's going to allow you to do more of a design anywhere, build anywhere strategy. The second theme that we have, or use case we have, is collaboration. So unfortunately, not everybody is in the situation where they can make the choice to consolidate. Maybe you're a supplier to a bigger organization and they happen to use a different CAD system. Or maybe within your company you've got different departments that happen to use a different CAD system and have no intention of changing. But you would still like to be able to work with them effectively, just as if you were on the same CAD platform. So this is collaboration. Now for this, we're introducing 3 new collaboration extensions. One for SolidWorks, one for NX, and one for CATIA. Working in conjunction with the open capability will also provide you the ability to receive automatic updates and to save your data out as SolidWorks, NX, or CATIA. So again, let's take a graphical look at how that works. So I've got my Creo assembly. I can now open up data from different systems. I'm going to bring in some SolidWorks data, some CATIA data, and some NX data. Now, just as if you were working on a Creo assembly and somebody had made a change to one of those parts, you will get a notification that that part is out of date, and you'll have the ability to update that part in session. Now, if that is a non-native format, the same thing will happen. So with the collaboration extension, you'll get a notification that your SolidWorks or CATIA object is out of date, and we will automatically update that for you to the latest iteration of the SolidWorks, CATIA, or NX file. Okay, so very quickly and very easily, you're able to work in an environment where you're working with data from different systems, and you're still able to receive updates from those different systems. Now, not only are you able to receive updates, but you can also reference that information as well. So just because this is not Creo data, I can still use it as a reference to build Creo data from it. And as I mentioned, in addition to that, with the collaboration extensions, you'll also have the ability to save your entire assembly out in one of those three key formats. So let's take a look at that in action. So again, I'm going to open up the same or a similar assembly of my truck. And in this situation, I need to bring in the cab. Now, the cab was built in CATIA, so I'm just going to open up my CATIA assembly and assemble that into place. Again, I could use any form of referencing here. I'm using coordinate system to coordinate system. Now I've got my cab in. I'm actually an engineer, and I'm working on the fuel tank. So I need to build some supports to hold my fuel tank. So I'm just going to start and build out some rough geometry to represent the brackets for my fuel tank. But the fuel tank itself is built by a supplier, and that supplier happens to use SolidWorks. So again, I'm going to open up the SolidWorks data of the fuel tank, and I'm going to assemble that fuel tank into place. Now I've got that fuel tank where I want it, I can go back to my brackets and start to do some more detail work on those brackets. I'm going to start by bringing or referencing some of the information from the SolidWorks fuel tank and use that to build out the geometry for my bracket and define a relationship between the fuel tank and the bracket. I can then continue to go and detail out this bracket, add some rounds to it, shell it, make it a sheet metal part, add some flanges to it, etc. What I can also do is now go off and start and build downstream deliverables. So I can go and build a 2D drawing, for example, of the fuel tank and also the fuel tank bracket. So here's my fuel tank drawing, and here's the bracket that I've just created. I can also go and start and perform some rudimentary structural analysis on that bracket. So now what happens, I go and I regenerate my model, and Notification Center, something that's new in Creo 3, will prompt me that I've got some objects that are out of date in my PDM system. The fuel tank's out of date, the cab is out of date, etc. So I'm going to say yes, I want to update those and replace them in session. And straight away you'll see the geometry of the cab changes, and also you'll notice the fuel tank updates. And that's a pretty significant change to the fuel tank. But because we referenced that SolidWorks data to build my brackets have automatically updated. My downstream deliverables have automatically updated. I can rerun my structural analysis on the same geometry, and we can see that that has updated as well. So this truly allows me for the first time to work collaboratively between different CAD systems. No longer do you have to be on the same system. You can now receive updates from different systems, and you can reference information from different systems and allow you to have associativity between those different systems. So in a nutshell, that is what Unite technology offers. So just to recap, there's two main use cases. The first one is consolidation, the ability to very quickly and easily bring in data from different systems and consolidate on a single platform. Whether you want to do that on demand, i.e. open the data up, and then as I touch an object, as I need to modify an object, at that point the system will automatically convert it to a Creo object for you, or whether you just want to use the import capability out of the box to be able to directly import that geometry straight into your system. And then the second use case is the collaboration use case, where you can now work concurrently and collaboratively with other systems, namely SolidWorks, NX, and CATIA, and have the ability to receive live updates as those engineers make changes in their CAD system. So hopefully that's given you a good look at what Unite technology is and what it can offer and what the use cases are that drive that capability. So moving on to the second theme of the release, which was concept design. Excuse me. So to begin with concept design, one of the first things we did is made some improvements to Freestyle. Now Freestyle was released in Creo 1, and Freestyle is about providing you with a tool to very quickly and easily rapidly build freeform geometry. Now users love Freestyle capability, but there were a number of cases where people still wanted to be able to drive that geometry parametrically. They still wanted to control it. And Freestyle, being free, didn't offer that capability. So what we've done in Creo 3 is provide you with the ability to now add parametric design intent to your Freestyle geometry. So in this example, I'm just going to build out my Freestyle geometry of this garden tool. And this is just standard capability that everybody gets in Freestyle. But at this case, I've now built my Freestyle geometry. This is the difference. Now I can select edges of my control mesh and I can align those to existing geometry. The top edge I align to some existing style curves and surfaces, and these front edges, I'm aligning those to an existing sketch. Not only can I align it, but I can also add continuity. I can say I want it to be tangent or I want it to be normal. Now if I go back to my sketch that is driving that geometry and make a change, my Freestyle geometry will update automatically. So for the first time, you're going to have the ability to build your freeform geometry very quickly, but also be able to control that freeform geometry parametrically. Moving on to Creo Layout, we've continued to enhance the capability of Creo Layout. Just to reiterate, Creo Layout is targeted at doing 2D engineering concept design work. So one of the first things we've done is we've added the capability to define and build sub-layouts. So sub-layouts allow you to split your layout project up into different chunks. Think of it almost as assemblies and sub-assemblies. What that allows you to do is then more effectively distribute that work out to a team. So I can split it up into different sections of my design and have different engineers work on those different sections just as they would with regular parts. In addition to splitting it up, I can also then import in or bring in different sub-layouts and assemble those into my master layout. So I'm just going to bring those in. I'm building out this gearbox assembly. Now I need to make a change to my design. So I'm going to go back to my main layout. But the first thing I'm going to do before I do that is I'm going to set my update control. Again, this is new capability in Creo 3 to say, don't just update, notify me of any updates before you do it and give me the choice to choose whether or not I want to update. So I'm just going in and making changes to my design here. I'm going to alter some of the geometry. I'm going to put some chamfers on. I'm going to build a new part in here. And when I've got this part finished, I'm now going to go back to my 3D environment. And when I do so, I'm going to get notified that I've got some geometry that is out of date. Now I could just update that, or I now have the ability to go in and show the differences. So before I do that change, I can evaluate what that change involved. So I can isolate that change, I can see what has changed, what has been modified, what has been added, what has been deleted. So I can get a clear understanding of the impact of the change before I actually go and update my model. We also show those changes in the model tree. So you can clearly see, based upon indications in the model tree, what has changed, what was added, and what was deleted. And obviously then when I perform the update, my geometry will update appropriately. But it allows me to clearly see the impact, or what the potential impact is of that change before I go ahead with it. So that was Creo Layout. Let's now move on to Creo Direct. So in the case of Creo Direct, we really focused on the assembly workflows. So here, directly from the model tree, I have the ability to create a new part, to activate the part. Notice how I'm working in a 2D cross-section all the time. So I can continue to work in 3D while seeing a cross-section of my part. I'm just going to build out some geometry on the top of this assembly. I have the ability to drag and snap to existing geometry in my assembly. So I can very quickly build that geometry out. I'm just going to turn off my sections. What we've also added is the ability to instantiate parts or assemblies as well. So very quickly I can create a shared occurrence of that whole subassembly and assemble it or reposition it in a different location, allowing me to very quickly conceptualize my design. Now, as I said, we focused a lot on the assembly workflow. One of those areas was on cross-sections. So we significantly improved the cross-section capability inside Creo Direct. So just as we have in Creo Parametric, you can now get a real-time cross-section feedback with a 2D section view. You can also rotate that cross-section. You also see in both the 3D view and the 2D view any interferences in real time. So you can clearly see that I've got some red area here that has my interferences in it. In addition to that, I can choose to exclude certain parts or assemblies from that particular cross-section. So as I said, I've got an interference that's going on down here. So directly in my cross-section, I can now go in and quickly make that change to my design to remove that interference. Again, the process here, or the improvements, are really around the speed and flexibility that you can now work within an assembly context. So back to Creo Parametric. We've added a new extension to Creo Parametric called Design Exploration Extension. So what is Design Exploration and why would you use it? So there are many, many cases today where you've got an existing design and you want to iterate upon that design, or you want to try out different design solutions for it. So what you tend to do today is you open up your assembly and you do a full save as of it or a backup of it to a different directory. And you'll then open that new one up, you'll make some changes to it, you'll save that off, and then you'll go and make a duplicate of that and try out some more ideas. The point here is that it's very time consuming to do that, and if you want to quickly change from one design idea to the next, it's very time consuming. You have to erase everything from memory, change your directory, load up the other design iteration. What design exploration allows you to do is take a single session and be able to create multiple design branches from it. So this allows you to very quickly come up with different design alternatives, maybe come up with different modeling approaches for a task, or also allows you to validate the consequences of a change without fully committing to that change. So again, let's graphically take a look at that. So let's say I've got an object, an assembly inside my PDM system. I'm at A.2. I'm going to check that out into Creo, and now I'm going to start a design exploration session. So at this point, I enter design exploration, and it's going to create a checkpoint for me, a starting location. I can then start to branch off my design, trying out different alternatives, and easily being able to switch between multiple different checkpoints. As I switch between those different checkpoints or capture those different checkpoints, I'm storing different ideas for my design. At any particular point in time, I can then choose one of those checkpoints and say, okay, this is the design I want to move forward with. I'm happy with this particular approach, and I'm going to make this the next iteration. So at that stage, I can then activate that. I'm back in my Creo session, and I can check that back into my PDM system as my next iteration. What we also have is the ability to store all that design work that you did and save it off in a file that I can then add as secondary content in my PDM system. So at any point in the future, I can come back and say, okay, when I was designing this particular assembly, what were the different design solutions that I evaluated? And why did I choose the solution that I eventually chose? So at any point, you can go back and interrogate that and see what those decisions were and why you made them. So let's take a look at it. So I have an assembly of a chair here. I'm going to start a design exploration session. I'm going to give it a name. Once I'm in this session, everything is the same. You'll notice there's this checkpoint tree, but I can just continue to design my part as I would normally. I'm making changes. I've just changed to having 6 legs, not 4. I can then say now at this point I want to store a checkpoint. This is a decision in my design process, and I want to store that so I can return to it. I can go back here. I've got an alternate to my design where the handles for the seat are at the back of the seat rather than the front. So again, I can store a checkpoint for that. I can then easily switch between those different checkpoints just by activating them. And my model or my particular design will change accordingly. Again, here I've made a change, and not to hide it, there was a failure. But that doesn't matter in design exploration. I can just say, okay, fine, I'm going to suppress it, but I'm going to keep on designing. I'm going to try out some different headrest designs. So here I'm using freestyle just to try out some different headrest ideas. And again, each of these I can store a checkpoint in the design so that I can evaluate it, come back and look and cycle through all those different design alternatives that I came up with for the headrest. So you can clearly see here that I've got the ability to not only iterate upon my design, but also create branches within my design. So if there's a particular item I like that I want to further evaluate that checkpoint, I can take that checkpoint and break it down and branch it out further. Still with the ability to quickly and easily switch between those different alternatives. In addition to that, I can use design exploration to evaluate what happens to a design change when a design change happens. Here I've told the system that I want to be notified when a change happens. So I've made a change to my skeleton model. I've been notified that there is some data that's out of date, namely my copy geometries. Now I could update these, but I don't know what the impact of that's going to be. Alternatively, I can go into evaluate what the differences are. So here I can clearly see that my design change that I made, I can see the original surface and the updated surface. I can then go into design exploration and update to see what the impact of that is. And in this case it fails, so maybe I don't want to fix it now, I'll fix it later. The point being that I can simply cancel out of design exploration and I'm back to where I started. So it allows me to try out those ideas without fully committing to that change. So as I said, that's design exploration. That is a new extension that we're adding in Creo 3. So that's concept design. Let's now move into general efficiency and productivity improvements inside Creo. So the first thing we've done with Creo 3 is completely revamp the help system. For the first time, the help system is available on the World Wide Web. That allows us to take advantage of Google search technology, which from a user standpoint means that you're going to be able to get more accurate search results based upon the input that you specify. We're also shipping the product, so for new users to the system, we're shipping the product with some startup tutorials. So very quickly, users are going to be able to learn how to create a part, create an assembly, create a drawing, create some mechanisms to allow them to get up to speed quicker. For existing users, we've also created over 100 What's New videos showing the new capability in Creo 3. It will explain how to use the capability, it will explain the workflows, it will explain the use cases. So again, allowing existing users to get up to speed quicker. We're also shipping the product, I showed this in an earlier video, with a new fastener library. So out of the box, you're going to have access to a library of ISO, DIN, ANSI, GIS standard fasteners, nuts, bolts, washers. The system has the ability to automatically create the corresponding hole geometry for you as well. So if you want to put a bolt through a couple of plates, you can also ask the system to create that corresponding hole for you for the bolt to go through. And it also has pattern capability automatically built in, so you have the ability to not only place that bolt, but automatically pattern it or ref pattern it when it's placed. Some feature improvements. We've added the support in our round capability for a chordal or constant width round. This chordal or constant width round can be a regular circular round, or it can also be a curvature continuous round. This is important for a lot of industrial designers, as chordal rounds create much cleaner and smoother geometry as opposed to a regular rolling ball round that in a lot of cases will disappear to a triangular patch. We're also, for the first time, shipping Mathcad with the Creo 3 release. And we're releasing an integration between Mathcad and Creo Parametric. You'll be able to embed a Mathcad worksheet directly inside your Creo part or assembly and be able to connect the Mathcad and Creo inputs and outputs together. So you'll be able to drive your design or the parameters of your design from a Mathcad worksheet. Edit references, or reroute as it used to be called, has also been overhauled in Creo 3. Now, there's a lot of work that's been done to this, but at a high level, we've made it a lot easier to now edit the references. We've made it a lot easier to understand what the references are of a particular feature. We'll show all those references for you in a dialog box. You can clearly see what those references are. When you click on them, it'll highlight the geometry on the screen. In addition to that, any one of those references, we also have the ability to show you any other features in your model that share that same reference and give you the ability to not only change that reference on the feature you selected, but also change the reference on any subsequent child features as well. The other capability we've added is the ability to show missing references. So there are a lot of occasions where you make a change and a reference is missing, the system can't find it, maybe the reference has disappeared or no longer exists. And the problem is you can't remember or don't know where the old reference was, and therefore how am I going to fix it? What alternate reference should I pick? So now when you pick on that missing reference in the user interface, we will highlight in the graphics area in red where that old reference was. So you can clearly see where it was and gives you the ability to then easily pick an alternate reference. We're introducing a new 3D thickness check. Again, this will be available with every single seat. It comes as standard. And this allows you really for plastic part design to be able to analyze your part and specify, for this part, I want a minimum wall thickness of, let's say, 1.5 millimeters and a maximum wall thickness of, let's say, 3 millimeters. The system will then go and analyze the geometry and color code the geometry accordingly to highlight areas that are less than the minimum or greater than the maximum wall thickness. So very quickly it gives you an idea of where you may have problem areas in your design. In tandem with that, we're also launching a new mold filling analysis capability. Now this comes in two forms. Firstly, out of the box with every seat, you're going to get a limited set of capabilities that is going to allow you to run a mold fill simulation. With the addition of a mold analysis extension, you'll then be able to perform more in-depth analysis and evaluate where your weld lines are, or what your fill temperature is, or your flow rates, to be able to really analyze your plastic part to make sure that you've got no problems when it comes to manufacturing. With Creo 3, we've also continued to extend and build out our graphics capabilities. One of the requests that a lot of people have is that they want to work in a more immersive design environment. They want to see realistic materials. So now in Creo 3 as standard, you're going to be able to apply realistic materials onto your model. You're going to be able to see realistic reflections. In this case, I've got some cast aluminium. I've got the ability to control the height of that casting effect in real time. I see real-time reflections. The system understands the difference between a plastic component and a metal component. The reflections are different and it will highlight or render it accordingly. Now this is all real-time. This is not photorealistically rendered, but I also have the ability to control the environment that that object sits in. I can specify or rotate the environment, the HDR image for the environment. I can scale it, and I will see the reflections on my model updating in real time. And as I say, this is not photorealistically rendered, so it's not some static image I'm creating. This allows me to really work in this immersive environment, so I can continue to design while seeing these realistic reflections on my model. And if you happen to have the advanced rendering extension to do a photorealistic rendering afterwards, the results that you get are very closely matched between this immersive environment and the static photorealistic rendered environment that you get. Creo Simulate also had some improvements in it. Mainly here we focused on adding support for sliding contact with friction. You can see a simulation of it here. And we also improved the results workflow and results display. Flexible modeling also had a number of enhancements made to it. We added additional support for round and chamfer handling, as well as we introduced a new flex pattern capability. One of the more exciting areas that we added as well was now support for tangency handling or tangent propagation. So in this scenario, as I move this one surface, I have the ability to now add conditions or constraints to my geometry to tell certain portions of it to remain fixed as I move it. If I fix this dark blue area, that round will stay fixed and the rest of my geometry will update accordingly. Here I've got a particular boss. I now have the ability in flex modeling to say pattern that boss, and I'm going to do a fill pattern. Now you'll notice this boss has a round around the base of it. So I'm going to take that and I'm going to fill in this whole area with that shape. I'm going to choose my pattern type and my spacings, etc. And when I pattern that, you'll see it creates all the bosses, but it also handles the topology change that happens around this different layer. Not only that, but I can then go in and make a change to any of those instances, and all instances, and it will propagate that change to all the instances of the pattern. This final change here is something that is available to all pattern types. So just to reiterate, you no longer have to make the change to the pattern leader. You can make a change to any of the pattern instances and still reference pattern that to all of the remaining instances. So ECAD collaboration extension has also seen some improvements. So we've introduced a new assembly type specific for ECAD design. We've also introduced support for flex boards. So now you have the ability to create flex boards or rigid flex boards. You can see here how the green board is formed around my geometry. We have the ability to take that and flatten it. When we flatten it, we also will make sure that we flatten any components that are placed on that board. So the components will move with the board when it is flattened. We're also introducing a new harness manufacturing extension. This is really a one-button operation to take a harness and flatten it and create all your 2D documentation associated with it. So it'll create your wiring harness, it will create all your bill of materials for your wiring harness in a one-button operation. Manufacturing also saw a lot of extensive work. So one of the big focuses on NC was support for multitask machining and the synchronization between that. So we support up to 4 heads and 2 spindles, and we can synchronize the operations of that. For 4 and 5 axis machining, we've also added dynamic tool axis definition. So in this top right image, as I'm creating my 5-axis trajectory milling sequence here, I have the ability to pick any point along that trajectory. I will then get a 3D dragger, and I can use that dragger to adjust the orientation of the tool at any particular location. The system will then show you the interpolated result of that tool as it moves through its cycle. And we've also made some further enhancements to volume milling to enhance and improve the capability we have there. So just to finish off, a high-level look at the timeline. So obviously Creo 3 F000 is available today. In October we'll be shipping M10, and in M10 we're going to be adding support for the ability to import in Solid Edge, and we'll also be adding the mold analysis extension that I talked about. So that will come in M10. Then around December time we'll have M20. M20 will provide the file open and conversion on demand capability that I talked about at the beginning with Unite technology. So that will provide you automatic updates for SolidWorks, CATIA, and NX. And we'll also be introducing the Mathcad integration that I talked about as well. For those of you on Windchill, Windchill 10.2 M30 will be the release where we support the full Unite technology with both Windchill and Creo. So taking a look at some other logistics of platform support. So here we, with Creo 3, we support Windows 7, Windows 8, and Windows 8.1, both on 32 and 64-bit operating systems. We have Windchill compatibility with 10.1 M40, 10.2 M20, 10.2 M30. We've also continued to build out our virtualization approach. So we have support with Citrix. We're also adding a new virtual GPU with Citrix 6.2. This allows you to take a system with a graphics card in it and be able to virtualize the graphics card, so share the graphics card between multiple users, making the use case far more compelling for virtualization. And finally, we have Creo Sketch. So for those of you that don't know, Creo Sketch is a free application available to be able to do freehand 2D sketches. In Creo 3, we've launched it on the iPad, so you can go to the Apple iStore and download Creo Sketch for free and be able to come up with your 2D concepts very quickly in a 2D environment. You can then take those concepts and bring them directly into Creo Parametric and use them as, or use the image as an underlay for designing, but you also have the ability to use the curves directly inside ISDX to build your geometry from. So hopefully that's given you a good overview of some of the capabilities, some of the key capabilities that are available in Creo 3.0. We've got 10 minutes left. I'm open to answer any questions you might have.
Thank you, Paul. I don't think we have any questions on deck as of now. If we want to wait a couple more minutes or 30 seconds or so, we can do that and see if any of you guys have any questions. All right, I'm not seeing anything come across, so if you all have any questions that you think of in the interim, please feel free to reach out to a TriStar representative. We'll be having a few more of these presentations coming up in the rest of this month and also September, so look out for those at tristar.com/events. As mentioned before, this webinar was recorded, and it will be in the TriStar Resource Center hopefully by the end of the day. You can reach the Resource Center by visiting tristar.com and clicking Resource Center at the top right of the page. Thank you all for attending again, and thank you, Paul, again for your time. Have a great rest of the week, everyone.
Thank you very much.